So I'm just going to quickly go through the answers for this. So it starts off with 11 failures and 1 passing. And let's see. So I'm going to walk through it with you. So here's one assertion. It says, a function's local scope variables are not available anywhere outside of that function. So here we have this function called first function, and we call first function here. So then we enter into that function body. We set local first fn to the string inner, and then we exit the function. All this is doing here is it's stopping it from, whenever you have an error, it will stop running your code and it will just break everything. This will stop that from happening, so it will run the subsequent lines of code. And this one says expect actual to equal what? So we're setting actual here.
Local to first function.
What string?
The one that inner.
To inner?
Right there.
Like this?
Oh, what string?
So we can check it. So I just saved. So I just saved that. And we can check it by coming into our spec runner and refreshing it. And we see that that didn't pass. So there's some assumptions here that we...
Why did you skip the test above?
Oh, did I skip the... Oh, whoops. Sorry. Oh, I'm in the middle of the screen. So sorry. Let me start from the second one. So this one's the first one. Here's the second one. So the first one is inputs to a function are treated as local scope variables.
Is that a true statement?
Yeah. So you want to. It's a true statement, and then the code, you're trying to prove it right. So it's testing for this rule. So we have this function, and it takes a parameter called name. And then here we're calling function to equal with inner. And so the parameter is now holding the value inner. And so actual equals inner. So we type in inner, and then we save it. The saving part's really important. And then we go to our test, and then we refresh this page, and we see that it passed. Cool? So, and then so the point here is that parameters to a function, or I'm sorry, arguments, whatever your input is going to be local to that scope. So a function has access to the variables contained within the same scope that the function was created in. So here we created this variable outer. We have this function here that we call, and we say actual equals name. What do we expect that to equal?
Outer.
Outer.
The kid can reach into the parent, but the parent can't go into the blender.
Yeah, exactly. No parents in the blenders. I don't want that. And then we can refresh it. Awesome. So that passed test as well. That test passed as well. All right. So now we're back to the other one. A function's local scope variables are not available anywhere outside that function. So here's a function, first function. We set that variable, that local variable, to inner. We call it. And then here we are, this is kind of a hint that it's expecting it to throw an error when we call this function.
No.
What is this going to be?
Null,
No.
Why is it null and not undefined?
because it's not declared anywhere in the global scope or in the scope outside of first function.
That's a good guess.
Is it because of the expect thing? It's so that the code doesn't break?
Actually, it has something to do with this before each. So before each, of these it functions, it's going to set actual to null.
Right. But because that expect doesn't actually run the code to set it to undefined, it just keeps it at null?
So yeah, every time it will set it to null. It will reset it to null every single time. So if we didn't have that function there, it would keep holding the previous value of actual from the other exercises, if you're not careful.
No, I understand that, but
Mhm.
to make this exercise correct, the one we're on now,
Mhm.
actual is expected to be null. But the only reason is that actual really hasn't changed because the before function changed it to null.
Yeah,
We started
exactly.
as null. Nothing's changed it.
Totally.
And the reason nothing's changed it, I think, I guess my question is because you have that expect statement that kind of like, if you catch an, if it's going to be undefined or an error, then just leave everything the way it was.
Right. It's because, yeah, exactly. Because this local, the first function, since it doesn't exist in the scope, it'll throw an error,
Right.
and it would stop running the code.
we're
So
catching-
this actual doesn't have access to this variable.
Right.
So
Yeah.
she didn't have that before, what was it called, before each
Mm-hmm.
test at the top? It would be outer, because outer was the result of the previous test case.
Mm-hmm.
Okay.
Yeah.
Got it.
So the next one is a function's local scope variables are not available anywhere outside that function, regardless of the context it's called in. So we have a first function here, and we have this variable first, and there's a little hint here. It says, although false, it might seem reasonable to think that the second function mentions the local second function should have access to the local first function variable, since it's being called here from within the scope that variable is declared. This is a tricky one. So we have our second function here. Oh, sorry, we call second function here, but since this isn't run yet, we actually even haven't gotten there. So we declared second function actual equals local to first function, and then we expect this to throw. So this is where we're calling our second function in here. Oh, I'm sorry. I actually think it's going to call first function first here. And where that goes, it goes into this inner block, declares this local to first function. Then it calls second function. And then second function is setting actual to local first function. And this is tricky because this is something called lexical scope, if you want to read into it later, is that this doesn't have access to the local first function. So what do we expect this to be?
No.
Let's double check it.
So blenders can't access sibling blenders. I mean, are function one and second from first like siblings, if you will?
Yeah, you could call them siblings, I guess. But the point here is that, siblings can't access inside other functions either. Yeah. Even though it might seem like you could because you're calling it from within that function. Cool. So if an inner and outer variable share the same name and the name is referenced in the inner scope variable masks the variable from the outer scope with the same name. This is from the slide where I called precedence. This renders the outer scope variables inaccessible from anywhere within the inner function block. So what's this one? Oh, so we have a function, we have this variable outer, and then we have this function that has the same name. Reset to inner. We set actual to same name. What are we going to expect actual to be? Anyone? I hear whispers, but I can't understand them. What about Kim? Did you get this far?
No, because I didn't know what throw meant. I don't do unit testing, so I don't know any of that stuff.
Yeah. No worries. Anyone else get this far?
I'll say outer.
Outer? What do you think? You think it's going to be inner? You're right. It's going to be inner. Why is it going to be inner and not outer?
Because
Because it only gets as far as the.
Hmm? Because if we think about the way it's called,
Oh.
so we call this function. So first we set outer up here, and then we say, awesome, there's this fn function, we skip it, we call it, and then at this point we enter into this, to the function body. Now we set same name to inner, and at that point we're setting actual to same name, and at that point it's inner, and that's why when it's evaluated down here, it's inner.
I was looking at the bottom, the next intercept.
Okay, looking ahead. Awesome. So the next one is if an inner and outer variable share the same name and the name is referenced in the outer scope, the outer value binding will be used. So here we're declaring same name, great function, we skip over it, we call the function, we enter into the function body, we assign same name to inner, we exit here on line 85, and then we set actual to same name. And since actual is in a scope that's outside of this function, it only has access to the same name within the same scope. And so that means actual is going to be
Outer.
Outer,
Outer.
yes. Then we save it, and then we can check it and make sure we're right. Awesome. We're starting to get more greens. So a new variable scope is created for every call to a function as exemplified with a counter. So we have our fn function. We say cool, we store it, we skip it, and then we call it. And then we call it, we enter into the body. We say var inner counter equals inner counter or 10. And so if inner counter, so if this is undefined, it will be false and it will skip to the right side and it will be 10. Otherwise, inner counter will be inner counter plus 1. Do we have an inner counter? Okay. Oh, I see. So if there's no inner counter already, then it's going to be 10. And at this point, it's going to be 11. And then we set actual to inner counter. So we call it once. And what is this going to be? 11. And then we call it again. 11. So it's going to be 11 because every time we call the function, it creates a new scope. And so inner counter is never going to change because it's always going to start off as undefined. Great. So a new variable scope is created for each call to a function as exemplified with uninitialized string variables. So here we have our function again. We skip it, right, to the end. We call it. We go inside and we say we initialize a local variable at undefined. And it says if local variable is undefined, enter into this block. So actual is now alpha. And then we're going to skip the else. And then we're going to set this local variable to initialized. And now we're going to call the function. The first time you call it, what is it going to print out? Alpha, exactly. And then if we call it again, so we call it again.
That's initialized.
Well, let's think about how it runs. So we call the function, we go back up here, it's initialized again as undefined. So it says if local variable is undefined, enter this block. And it says actual alpha, it skips it, and then it says local variable is initialized. So,
So I got tripped up on this one. I thought local variable was null instead of undefined. Could you maybe touch on why it's
Sure.
not null?
Sure. So the reason that local variable is undefined is because whenever you don't explicitly define a variable, it's undefined. You have to actually set something to null. So JavaScript will make it undefined automatically. So in general, if you want to set something to empty, it's best practice to set it to null and not undefined so that you can kind of differentiate between that. And you'll notice that we set actual to null before each time. That's us manually setting it. But here, we're just initializing a variable and it's just going to be undefined. The same with if you have parameters that don't have an argument pass, when you reference those parameters, they're going to be undefined. Yep. So what did we decide this one was?
Alpha?
Alpha. Cool. So, let's check it. Awesome. So an inner function can access both its local scope variables and variables in its containing scope, provided the variables have different names. So here we have our outer name, then we have fn again, we skip it, we call fn, we enter into that body, we set inner name to inner, and then actual is inner name plus outer name. So what is actual?
Inner outer?
Is inner outer. And the reason that actual can be set like this is because it's a global variable. And we see that it has no var. So that's something important to note as well. So we check it. Great, only two more. Let's see. Between calls to an inner function, that inner function retains access to a variable in outer scope. Modifying those variables has a lasting effect between calls to the inner function. So here's our outer counter, and we have a function. We skip it, we call it, we enter into the body, and outer counter equals outer counter plus 1, so outer counter is 10. So that means outer counter is now 11. And we're setting actual to outer counter. So what is actual?
11.
Yeah. And then we call it again, call the function. We go inside the function body. Outer counter, what's outer counter again? 11 plus 1 is 12. So now now actual is set to outer counter, which is 12. So what should we expect actual to be at the second call? 12. And the difference here is that our counter is outside of our function. And since our child function here, our nested function, has access to that outer counter, it can change it, but it still has reference to the value. Cool, let's save it. Great. And then our last one, the rule about retaining access to variables from the outer scope still applies even after the outer function call that created the outer scope has returned. So we have our outer function. And remember, we skip over it. We call, oh, where does this end? Oh, I see. So we skip over it down here. And then we run the outer function. we call it, and we go inside of the function body. We set counter in outer scope to 10. And then we have our incrementing function, which we skip. We call the incrementing function, and we say counter in outer scope +1, and we set that. And then we return here to our expect statement. We expect actual to equal what?
11.
11. And then we call our inner incrementing function again. And then what happens?
12.
12.
So this is like up to now, it's like the previous exercise.
Mm-hmm. It's similar, but the difference here is that we're explicitly inside of a function. And now what is this one? Oh, to be a function. Let's see. Oh, here we go. So I skipped this line. So then we have window dot retained inner function equals inner incrementing function. So remember, we put things on the window object that makes it global. And then we call it here again, retained inner function. And so once we call it, we go back in here, and then we do +1 again. And since we still retain value in its parent scope, what is it? It's 13. Cool. So any questions about that exercise? It's pretty in-depth. If you read through all these rules and here, these are basically all the rules for scope. So if you go through those a few times, you'll be mastered all the different scenarios for scope. Any questions? I like just one question.
And
So
if you click on them?
someone gives me one question, that'd be great.
So if you click on them, you get the actual...
Oh yeah, if you click on them, you can see the exercise.
So I have a question.
Mm-hmm.
I have one error remaining. I don't know which one it is.
Mm-hmm.
Again, how do we find which one it is?
Like the red X next.
Yeah. I can look at yours if you want. Yeah. Great.
There's a red X.
What it is?
The style sheet.
Yeah, the style sheet. There was an error with the style sheet.